Hello, my name is Delilah, and I'm a part of the Diabetes Monitoring App team with UCSD's chapter of Engineering World Health. This year, our goal was to create a culturally sensitive and educationally accessible diabetes monitoring app. Diabetes affects about 1 in 10 people in the United States, and although there are a lot of apps out there already, they often focus on complicated features and can be overwhelming and difficult to use for low-resource communities and vulnerable populations. Our goal was to fill that gap with a simple, user-friendly app that changes its user interface depending on the demographics that the user subscribes to when they set up an account. This includes customization of color scheme, recipe suggestions, exercise suggestions, and access to a diverse group of health coaches to answer any questions they may have. If you think our project sounds interesting, come check us out May 27th, 5 to 7 p.m. on Remo for our design showcase. Thank you.
We are the ARM support team, and we spent this year researching and designing a device that will help children in sub-Saharan Africa who are impacted by spastic cerebral palsy.
Spastic cerebral palsy causes muscle spasms, poor muscle coordination, and makes it difficult for affected children to complete activities like writing and typing, which are critical to their education.
We have gone through several prototypes, but have come up with a final design that is an elbow support brace, which will help stretch the muscles of the arm and prevent permanent formation of contractures.
Our device will be relatively simple and low cost, will require no electricity, and will be adjustable to grow with the child in order to provide years of muscle training.
We hope you stop by at our EWH showcase to learn more.
The project aims to reduce mass drug administration to treat soil-transmitted helminth infections, which are transmitted in the fecal waste of an infected person. Over 1 billion people globally are affected by these parasitic diseases, and the current solution is to administer packaged drugs to entire communities without individual diagnosis, because that requires time and resources such as trained microscopists, which are often not available in these underserved communities. However, mass drug administration is wasteful and often unpleasant for the communities because of non-lethal side effects such as nausea, dizziness, etc.
To address the difficulties of SDH diagnosis due to insufficient medical professionals, our team has developed a progressive web app that allows the users to upload microscopic images and provide rapid screening. We've developed a convolutional neural network that detects soil-transmitted helminths in microscopic images of fecal samples that works in the back end of our progressive web page. Convolutional neural networks are the most common method for analyzing images with a deep neural network. Our program is trained on a data set of more than 1,000 images containing fecal samples infected with 3 types of SDHs.
Our CNN is able to classify previously unseen images as positive or negative for parasitic infection with 91% accuracy, and only 2% of infected samples were falsely classified as negative in our tests. Our progressive web page only requires internet on the first use and for updates, and has offline capabilities with the use of service workers, which is an important functionality for our target communities. We expect our project can serve as an effective pre-diagnostic tool for undeserved regions, and can narrow down the population that actually needs the medications for the parasite.
Thank you for listening.
Our design is a newborn resuscitation training device. The problem that we are addressing with our design is infant death related to birth asphyxia, which is a preventable issue, but primarily affects regions that we are focusing on in southeastern India, which have death rates from 23 to 25% from birth asphyxia alone. This is a problem that needs to be addressed, as low-resource communities shouldn't suffer from the side effects of these terrible deaths when they're preventable with proper training and technology.
So given this issue, we designed a solution that includes a BVM monitor to provide real-time feedback while also resuscitation is being performed. We also included a supplementary website that offers instructions for this resuscitation process in multiple languages, including English, Hindi, and Telugu.
Another component of our design is the training website. its purposes are to educate medical staff to successfully identify birth asphyxia, as well as to provide the proper resuscitation procedures. And the secondary purpose is also to provide documentation for our BVM monitor component, as well as its intended use.
So for the BVM monitor itself, we've designed a device which makes use of LEDs to provide feedback on optimal ventilation pressure as well as ventilation frequency. So for the Arduino microcontroller and the circuit component of the device, we've programmed it to light up if the barometric pressure sensor detects pressures exceeding or falling below certain bounds, and also blinks at a set frequency for the user to keep time with. The CAD model for the device, as seen in the bottom left, has been designed to be attached to a standard BVM or AMBU bag as an add-on, and is able to house not only the microcontroller, but also the pressure sensor and battery storage as well.